Okay, here's the video for 6-4. We're talking about analyzing graphs of quadratic functions. Okay, so if you look at the first example, we're going to graph our quadratic function, and then we're going to find the vertex, the axis of symmetry, the min-max value, the domain, the range, and the roots. Okay, so in our first few lessons, we did domain, range, and roots, and now we're going to do vertex, axis of symmetry, and min and max. Alright, so let's see what we have here. On the first one, we need to figure out which equation this looks most similar to. Okay, I would say ax squared plus bx plus c. Okay, so that means right now our a would be equal to 1, our b would be equal to 4, and our c would be equal to 3. Alright, so to find your vertex, you have a formula. Vertex, your x value is equal to negative b over 2a. Negative b is going to be negative 4 over 2 times a, which is 1. So now this is going to give us negative 2. So your vertex, your x, you know is going to be negative 2. Now to solve for your y, you have to plug your negative 2 back into your equation. So plug it back in as x and solve for y. So you would have y is equal to negative 2 squared plus 4 times negative 2 plus 3. So now you would get 4 minus 8 plus 3. Okay, so that would give you a negative 1. Put that up here. So now you know your vertex. You can pick your first point. So negative 2, negative 1. We'll go, let's see, negative 1. Yeah, negative 1. We can do 0 and 1. Okay, so when you put negative 1 in there, you would have y is equal to negative 1 squared plus 4 times negative 1 plus 3. So now you would get 1 minus 4 plus 3. So that gives you 0. So plug that in up here. So now if we put 0 in, I don't even know if I have to write out because you're going to get 0 plus 3. So that's 0, 3. And then your 1. Let's see, so put 1 in, so you would have y is equal to 1 squared plus 4 times 1 plus 3. So you get 1 plus 4 plus 3, which is going to be equal to 8. Alright, so now let's plot that. So we're going to have negative 2, negative 1. And you're going to have negative 1, 0. And then you're going to have 0, 3, 1, 2, 3. And then you're going to have 1, 8. Okay, your axis of symmetry is here because this is your vertex. So we're going to mirror our points over here on the other side. And get something like that. Okay. So now looking at this, we can fill in the rest. So your axis of symmetry, we already said, is if you folded this in half, it's going to go down the middle. So that is that x is equal to negative 2. It's always going to be your x point of your vertex. Okay, so that's another way to look at it if you're not looking at the graph. Now then min-max, okay. Now this is facing up. This is what they call facing up, okay? So that means the min is here because there is no max, right? It's continuing on forever. So there's a min, but there is no max. So your min is what you would say. You'd circle, there is a min value, and the min is going to be negative 1, okay? Right here. It's your y. Your min is negative 1. Okay. Now then, domain, looking at the whole graph, your domain is your x. So what is happening to x as this graph continues to get bigger, to grow, to go up? It's going to continue to go up, 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 and out to the right. And it's going to continue, since there's arrows, and it's going to continue to go to the right and the left. Your domain would be all real numbers. But your range, okay, your range is your y. So that's this part. And you can tell that on your range, which is your y, that it starts here and it goes up and it continues to go up. Okay, so starting at -1 and going up, but it's never going to be down here. Okay, so your range is going to be y is going to have to be greater than or equal to -1. Okay, and now your roots. Looking here, you can see you graphed your roots, and the first root was at up here -1, 0. Okay, and your second root is going to be at -3, 0. So you would put that -3 and -1 are your roots. Okay, so that's the first example. Fill that all in. Show it to you from a wide picture. Okay, so number 2 and number 3, there's only 2 more examples, but they're going to work the same way, okay? So we've done all of this before. There's nothing new here. We're just putting it all together, okay? So once you find your vertex, you plot your points and graph it. Once you get your graph, you can fill in the information about it, okay? So you need to look and see, does it have a min or a max? Let me show you the example of the one that's already done so you can see. So for example, on number 3, on the back, this is what it looks like graphed, okay? And I just wanted to explain the min and the max, okay? Because this means the min is going to continue to go down, so there is no min, okay? There is no minimum because this graph is going to go down forever. But it does have a max because it's never going to be greater than this point. So your max would be 8, right? Y is equal to 8 is your max, okay? So that's the difference in between this example where you would see a max and this one is where you would see a min. Okay, all right. So, I think that's it. I don't want to do another one. I might run out of space here and my video may cut short. So we'll do another example in class, but basically you just need to use your equations for number 2, figure out which one it looks most alike, and then solve for your vertex, just like we did on the practice problems in the last 2 days. Okay, and then you're looking at the graph, you need to fill in these. Domain is x, range is y, your roots are where it crosses your x-axis. Okay, your min and max, we just covered that. And your axis of symmetry is going to be where your graph is, where it mirrors, like where it divides down the middle. Okay, remember, axis of symmetry up here is your x point of your vertex. Okay. All right.